So in this triangle below, we have let's read the following slowly. We have E to meet the midpoint of AC. We have AD and BE intersecting at F, which is the midpoint of BE. So F is the midpoint of BE. And FC and EH intersect at G. Alright, given that AD is parallel to EH, we want to show that EH is 2 times of FD. So looking at this tool, okay, let's try to investigate. You should see some sort of it looks like parallel lines, right? So with these parallel lines, it'll be good for you to start to observe if there's any similar triangles involved. Now usually when you are asked to show a certain ratio, like this side is 5 times of that side, or something like this side times that side is equals to the number, like for example length AB times CD is equals to 3. So when you're asked to show like a product of two lengths or show a certain ratio, right, usually the ratio comes from proving of similar triangles. Alright, so let's take a look at this question. Now if we have AD, since we know that AD is parallel to EH, we can conclude that, well, these two angles are actually equal. At the same time, we can also conclude that these angles are equal. So if you consider the triangle, the first ones are consider the triangle triangle FBD and triangle EBH. Right, this is what we want to look at. We want to show that they are actually similar, so that we can compare the ratio of the two sides. Okay, so we can see that FD, you can see that angle FBD is equals to angle EBH, since it's the common angle. You can see that angle BFD is equal to angle FEH because of corresponding angles, and FD is parallel to EH. So that gives us the idea that using AA property, triangle FBD is similar to triangle EBH. Okay, now because they are similar, we can straight away assume that corresponding sides will have the same ratio, meaning if we were to compare this, that EH over FD, now this should be the same as BE over BF, and straight away you can see that because F is the midpoint of BE, right, so BE over BF should be equal to 2 units is to 1 unit, which is 2 over 1. Okay, so with that you can see that EH over FD is equals to 2, implying that EH is equals to 2 of FD, and we are done. Okay, so that's for the first part. For the second part, we're going to consider showing that AF is equals to 3 of FD. Okay, so let's erase it and start over again. Again, we are looking at AF, and we are looking at FD. So I'm looking at these two triangles, and I want to see it could be possible, and since we have already used we could be also looking at how we can link this to EH. So let's consider these two triangles, the first one as well as the second one. Okay, now since AD is parallel to EH, consider that triangle CEH is actually similar to triangle CAD. Alright, again, this is by using the similarity AA property. Alright, so again, you can see that the common ratio here is just 2, because you can see that since E is the midpoint of AC, you can see that EC over AC, the corresponding ratio is 2, right? So if we were to consider EH over AD, this is the same as CE over AC, alright, which is basically equals to half, as you can see straight away, because it's like CE over AC is half. Now the nice thing is, because we are trying to show FD and AF, you can see that EH, right, from earlier, EH can be written as 2 of FD, and AD here is basically FD plus AF, which is equals to half. Okay, and more or less you can see that we have our main characters coming out, which is AF and FD. So all you need to do is just cross multiply. You have 4 of FD equals to FD plus AF, and you cancel off. You have 3 of FD on the left, AF on the right, and yes, you are done with part 2.